Hello everyone, welcome to BYJU'S exam prep. So I am bringing another question for you by which you can easily understand a short trick how to calculate the average power of random process. So let's quickly move into the topic. So first of all, I am going to discuss about the autocorrelation. So autocorrelation for any wide sense stationary process depends only on the time delay between the two processes. So that is nothing but the two same process in fact. So that is Rx of tau, it is expected value of x of t and x of t plus tau. So you can see that same process you are using and the delay is just the tau, which is nothing but the difference between the t2 minus t1. So for this type of autocorrelation, you can have these two properties. So if you want to calculate the power through the autocorrelation, then you just need to substitute tau equal to 0. That's it. At tau equal to 0, you will get the average process of the random process, average power of the random process, and similarly you can calculate the average power of the random process by the power spectral density as well. If you calculate the total area under the power spectral density, you will get the average power of that particular random process. And if you are dealing in the frequency domain, then you just need to integrate minus infinite to infinite sx of f, and if you are dealing in the omega domain, this is 1 upon 2 pi minus infinite to infinite sx of omega d omega. So let's quickly go into some example that how can you calculate the average power. So suppose this is the autocorrelation function of any wide sense stationary process is given, and it is asked in the GATE examination to calculate the average power. And if you want to calculate the average power, you just need to put tau equal to 0. So you can see that at tau equal to 0 you have the value 2. So that means the average power of this particular wide sense stationary process is 2. So how quickly you can solve, you can see just you need tau equal to 0 you have to put. And this is another example by the power spectral density. So if you want to calculate through the power spectral density as it is given in the omega domain, so the average power you can calculate as 1 upon 2 pi integration from minus infinite to infinite excess of omega d omega. So when you will integrate it from minus infinite to infinite, 9 upon omega square plus 64 d omega, you will get 1 upon 2 pi, and then this is 9 is common, 1 upon a which is 8, and 10 inverse omega upon 8. So you will put the limit minus infinite to infinite, you will get 9 upon 16 pi, and when you put infinity you will get pi by 2, and when you will get put minus infinity you will get minus pi by 2, so it will become plus pi by 2. So the answer will be 9 upon 16. So time average power you can calculate by simply calculating the area under the power spectral density. And if you know about the relation between autocorrelation and power spectral density, then also you can convert it into the autocorrelation by taking the inverse Fourier transform. And when you take the inverse Fourier transform of this, you will get the autocorrelation and again put the tau equal to 0. So this is the short trick for this session, and in the next session we will take another very short trick to calculate some other question, to solve the other question. Thank you for watching this. Stay tuned with us and subscribe the channel.